An uncharged capacitor of capacitance 100 microfarad is connected to a battery of EMF 20 volt at t equals to 0 through a resistance 10 ohm, then at which the rate of energy stored in the capacitor is maximum. So we have a capacitor here whose capacitance is given as 100 microfarad, is connected to a battery EMF 20 volt. So this is our battery that has a EMF of 20 volt, and there is a resistance of 10 ohm in the circuit. Time at which the rate of the energy stored in the capacitor is maximum. So this is a case of charging of capacitor, and for charging of capacitor we write charge on the capacitor Q here as Q equals to CV 1 minus e raised to the power minus t by RC. So this is the charge on the capacitor. Now energy, if I write energy is how much? Energy is Q square by 2C. When charge is known, we can write the energy in this form. So this is our energy, and here capacitance is constant. Now we have to calculate the rate of energy stored. So rate of energy stored is how much? Rate of energy stored. So rate of energy stored, I will be writing it as a dE by dt. So dE by dt will be 1 by 2C, and this is 2Q, and then this is dQ by dt. This is rate of energy stored. Now in the question they are asking us that the time at which the rate of energy stored in the capacitor is maximum. So this function has to take its maximum value. Means I will say that for dE by dt to be maximum, for dE by dt to be maximum, d of dE by dt must be equals to how much? 0. So if I double differentiate this function, let me simplify this. So this will become Q by C dQ by dt. dQ by dt is nothing but this is I Q by C here. And dQ by dt, if I calculate here dQ by dt, then this is CE and e raised to the power minus t by RC by RC. So this is E by R e raised to the power minus t by RC. So this is I. And what is di by dt? So this is I here. And if I calculate di by dt, because I will also require di by dt, so let me calculate this. Di by dt will be E by R, and this will remain as minus e raised to the power minus t by RC, and minus differentiation will become minus 1 by RC. So this becomes E by R square C, E by R square C e raised to the power minus t by RC. Now I have to use this whole thing in this equation. So first differentiate this dE by dt. When you differentiate dE by dt, you will be getting here as I by C dQ by dt plus this will become Q by C into di by dt. Chain rule I have used here, a product rule. Now we have to equate it to 0. So I is here, we have calculated the value of I. So if I substitute the value of all the things that are here, you can see C and C will cancel because they are denominator. So simply I will be writing it as a I dQ by dt equals to minus times q di by dt. I dq by dt. This is I dq by dt. Lot of calculations are there, but these calculations are like very elementary calculations, so that can be done easily. Now substitute the value of I, that is e by r e raised to the power minus t by rc, and then dq by dt can be written as this is again itself I, so I will be writing it as a e by r e raised to the power minus t by rc equals to minus of q, so minus of q is basically cv 1 by e raised to the power minus t by rc. Cv can be also written as here, it's you better write it in terms of e just to avoid any confusion, so I am writing it here e. Small correction is there, here it will be ce 1 minus e raised to the power minus t by rc, that is q, and minus sign is there, and dq by di by dt is again minus of e by r square c e raised to the power minus t by rc. So you can see minus and minus will cancel each other. Now if I simplify all these expressions, you will get here e square by r square e raised to the power minus 2t by rc, that should be equals to you can see that c and c will cancel here, and you will be getting e and e, that will become e square by r square, and then this is e raised to the power minus t by rc minus e raised to the power minus 2t by rc, because this is e raised to the power minus t by rc will come here, so here it will become this expression, and with this it will become 2. Now this will come to this side, we can also cancel these two together, so I will get 2 e raised to the power minus 2t by rc, that should be equals to e raised to the power minus t by rc. So if I further solve this one, I will be writing 2 by e raised to the power 2t by rc equals to 1 by e raised to the power t by rc. So in this we will get e raised to the power t by rc equals to 2. So we will take log, and then we will solve after taking log, and we will get here ln on both sides, so we will get t by rc equals to ln 2. So t we will get here as rc ln 2. So this is the time when the energy stored in the capacitor is maximum. Okay, so these are the things we have to just follow each step, and then we will reach to this answer. Now if you substitute the value of rc from here, so you can see r is 10 ohm and c is 100 microfarad. So r is here 10 ohm, so 10, and c is 100 microfarad, so 100 10 raised to the power minus 3 minus 6 microfarad ln. So this is ln 2 millisecond, because 10 raised to minus 6 and 10 raised to 3, 10 raised to minus 3, that is equals to millisecond. So we will get the time here as ln 2 milliseconds. So the correct option should be option C.